Hello friends, welcome to the channel Study Guide. So friends, here we have bring the SSC J 2018 solution. Okay, for the first time in the YouTube. Okay, because we are very interested to solve the SSC J question paper of 2018. Okay, later we will solve the previous year 2017 and 2016 and 2015, 2014. Okay, you can find all the solutions in some different books, but we will approach it in a different way. Okay, but the question is right now we are very interested in SSCJ 2018 solve. Yeah. Okay, as that is not found in book. Okay, let us first go to the solution. Okay, so in this session we will solve 23rd of January 2018 second shift. Okay, 23rd of January second shift solution. Okay, the QID is the question ID given by the SSC. Okay, the question ID is given by the SSC. Okay, if you solve this 1200 question paper, 1200 question, okay, you will get a rough idea about the SSC JEE preparation. Okay, later in our videos we will discuss the SSC JEE preparation strategy. Okay, later, not right now. Okay, what is the SI unit of electrical energy? Okay, watt, unit of power, volt, voltage, ampere, current, and joule. Okay, joule is the unit of energy. Okay, joule is the unit of energy. So what will be the correct answer? What will be the correct answer? The correct answer will be the joule. Okay, correct answer will be the joule. Coming to the next question, which one of the following is the correct expression for the heat generated in a conductor? Okay, the options given for the SSC said that no correct answer. SSC has said in the final answer key that no correct answer and benefit to all. That is, whatever the options given in the question paper, and that is not suitable. Okay, what is the heat generated in a conductor is given by the H equals to I square RT. Okay, H is given by I square RT. Okay, next question. Which one of the following statement is true? So, a very simple and conceptual question. Okay, let us start each and every one. Okay, the equivalent resistance in series combination is larger than the largest resistance in the combination. Okay, the equivalent resistance in the series combination is larger than the largest combination. Okay, now a very simple thing. If R equivalent, if equivalent equals one is 5 ohm and another is 10 ohm. Okay, so what will be the equivalent? The equivalent will be 15. Equivalent will be 15. Now that means the equivalent resistance of a series combination is larger than the largest resistance in the combination. Same as okay, all three options can be eliminated and we would not read all the other options. Okay, now let us move to the another concept, that is, if the equivalent resistance in parallel, okay, if the equivalent resistance in parallel combination is larger than equivalent resistance in the parallel combination is larger than the smaller than, okay, in that case the smaller than the smallest resistance. If I take this 5 and 10 in parallel, okay, what will happen? 5 into 10 by 10. Okay, 5 into 10 by 10, and what will be the 50 by 10, that is 5 into 10 plus 15. Okay, 5 into 10 plus 15. Now 50 by 15. Okay, so 3 point something. Okay, if it is 3 point something ohm, that means the equivalent resistance in series combination is larger than the largest resistance. Here the largest resistance is 10 ohm, so it is larger than the largest resistance, and here the smaller resistance is 5 ohm, so 3 point something is smaller than the smallest. Okay, in series case larger than the largest, and in parallel case smaller than the smallest. Okay, so coming to the next point, the resistivity of a conductor depends upon, okay, resistivity of a conductor depends upon, sometimes a lot of students write this equation, R is equals to rho L by A. Okay, and they write that is rho equals to R A by L. Okay, From this formula you can find the dimension of the row. From this formula you can find the dimension of the row, but nothing else. Okay, row is a physical property of a matter, and it's exceptionally depends on the property of the matter. Okay, very property. If you change the matter, okay, then the property changes and then the row changes. Okay, if I look at the options, options, the shape of the cross section will not be a answer. Shape of the cross section, first shape of the cross section will not be answer and will never be answer. Okay, but so what are the possible condition, possible options? The possible options are, okay, the possible options are degree of illumination, yes, it is a possible answer, and temperature. Okay, okay, degree of illumination will enhance the temperature actually. Okay, so the best answer is temperature. Okay, cross section will never be a answer. Cross section will never be a answer. Okay, degree of illumination and temperature both are very suitable, but temperature is the best answer. Okay, temperature is the best answer because the degree of illumination already changing the temperature. Coming to our next point, determine the energy stored by a 0.4 Henry inductance if the current flowing through it is 2 ampere. Okay, so what will be the energy stored? Energy stored E, that is equals to half into L into I square. Okay, what is half? Now half into L. What is L? L is given by 0.4. L is given by 0.4 multiplied by, what is I? I is I square, that is 2 into 2. Okay, I is 2 into 2. Now I will eliminate this 2. Now 0.4 into 2, that is 0.8. Okay, 0.8 joule. So the energy stored in the inductor will be 0.8 joule. Okay, next in our next question, what is given? What will be the voltage across a 8 Henry inductor when the rate of change of current in the inductor is 0.5 ampere per second? Okay, so what will be the formula? What will be the formula for this one? The formula will be V equals to L di by dt. Okay, what is di by dt? That is the rate of change of current, and this is ampere per second. Okay, ampere per second. Now L is already given 8 and di by dt is already given. Di by dt is given. What is di by dt? Di by dt is 0.5. Okay, so 8 into 0.5, that is 8 into half, that is 4. Okay, so the answer will be 4 Henry. Now next question. Next question, what is the equivalent capacitance in 3 capacitors connected in a series? Okay, if the capacitors are connected in series, what will be the formula? That is C1 C2 by C1 plus C2. Okay, okay, don't make a mistake that you will add a formula like this one, C1 C2 C3 by C1 plus C2 plus C3. Okay, don't try to write this formula. Okay, this formula never exists. Okay, so what you have to do, very simple thing, that you have to calculate. Okay, you have to calculate very step by step approach, and I would say if your calculation is faster, so you can do it without any calculator. Okay, without any calculator. How can you do it without any calculator? That is 0.4 into 0.2. Now if I do it in our mind, okay, 0.2 into 0.4, if your calculation is faster, you can calculate from your mind, and the answer will be 0.4 by 3, and this will be a very simple one. 0.02 into 0.04 divided by 0.02 plus 0.04. Okay, now what will happen? Now it will result in 0.02 multiplied by 0.04 by 0.06. Okay, 0.06. If I make an eraser, this erase this one, erase this one. Okay, so okay, what is happening out there? Okay, if I eliminate, okay, this point, so what will happen? 2 and 6, so 2 by 6, 3. Now this much calculation you can do it in your mind. Okay, this much calculation you can do it in your mind, and your calculation should be faster. Okay, 0.04 by 3. Now you have to make a parallel combination of 0.04 by 3 with the 0.08. Okay, there is another capacitor 0.08. No need of any calculator, no need of any calculator. So 0.04 by 3. Okay, as I am using my digital pen. Okay, first I am using my digital pen, and this digital pen is not as fast as our ballpoint pen. Okay, first let me talk that our digital pen is not fast as fast as you can see. The digital pen is not so much faster than our ballpoint pen. Okay, so I have to take some time, okay, to solve it. But if you solve it, okay, by my process, okay, you can solve it on a very fast. Okay, try to first try to take a copy and a pen, okay, and practice with me. Okay, and it will bring you a lot of confidence, and it will bring you a lot of speed calculation. Okay, first, okay, keep it same. Okay, in digital pen we can't use very fast. Okay, because the computer cannot take fast. Now what is the LCM of the denominator? That will be 3, 0.04 plus 3 into 8, 24, that is 0.24. Okay, now what will happen? So 0.04 into 0.0, okay, this 3 will be eliminated, okay, from the denominator of the both of them. Now 0.04 plus 0.24, that will be 0.28. 0.28. Now 0.04 into 0.08, keep them, okay, don't multiply them, 0.08. Okay, so 0.04 to 28, 4 into 27. Okay, so 0.08 by 7. Now one thing I can tell to you, okay, there is a lot of problem in the digital pen, but in the ballpoint pen there will be no problem, and your calculation will not take so much time. Okay, 8 by 7, but we can write 8 by 7 into 1 upon 100. Why? Because this is 0.08. So 8 by 7, but 8 by 7 will be 1 point something, 1.1. Okay, and if I write 1.1, if I write 1.1 divided by 100, what will happen? 0.011. Okay, this point will approach 1 and 2. Okay, so 0.011, and that will be the correct answer, option number 4. Okay, so whatever I have done, I am repeating once more. That is 0.04. I first make a combination of 0.04 and 0.02. Okay, that is very simple approach. If you calculate it from the mind, then the answer will be 0.04 by 3. Okay, now if you calculate again C1 C2 by this one, okay, and this much calculations is very simple. Okay, but your calculation should be faster, so that you can answer this question in a very proper time. Okay, not a very conceptual, but very simple calculations were there. 8 by 7 into 1 upon 100, that means it will be 0.011. Okay, no calculator needed in the exam hall. Okay, let us move to the next question. Okay, what is the question said? The question said that determine the voltage of a battery connected parallel plate capacitor. Okay, what is given? Parallel plate capacitor with air field. Okay, very important, air field. Why? I'm telling you right now. When the area of the plate is 10 square centimeter and the separation between the plate is 0.5 millimeter, and the charge stored on the plate is 20 picocoulomb. Okay, so what will be the formula we will use here? Q equals to CV. You know that formula. Now what will be the V? Okay, we have to find V. Will be Q upon C. V will be Q upon C. So very easy. So Q is already given. Q is 20 picofarad. That means 20 into 10 to the power minus 12. Okay, 20 into 10 to the power minus 12 coulomb. Okay, now we have to calculate the C. What is the formula for C? C is equals to epsilon naught epsilon R A upon D. Okay, now as it is a AR capacitor, what we can write here? As it is a AR capacitor, we can write that the epsilon R is 1. Okay, epsilon R is 1. As it is a AR capacitor, epsilon R is 1. If the epsilon R is 1, okay, if the epsilon R is 1, the formula will become epsilon into A by T. Okay, what is epsilon? What is the value of epsilon? 8.8. A lot of trouble in the. Okay, 8.85. Okay, I don't know why it is so irritating. Okay, okay, C equals to 8.85 into 10 to the power minus 12. Okay, minus 12. Okay, multiplied by how much? Epsilon A. What is A? A is given by 10 square centimeter. A is given by 10 square centimeter. So 10 square centimeter to meter. If I convert it to centimeter to meter, what will happen? 10 to the power minus 4. Okay, 10 into 10 to the power minus 4 meter. So if I write it clearly, 8.854. Okay, 85 I can take. If I can take 85. What is the problem? Into 10. Minus 12 into 10 into 10 to the power minus 4. Okay, now C A by D. What is the D? D is given here 5 millimeter. Okay, 5 millimeter. Okay, as I am using the digital pen, yes, there is some problems in the digital pens, but in your ballpoint pen there will be no problem, and you will not require as much as time what is I am taking. Okay, but I am just elaborating it, but I don't take so much time. Okay, if 10 to the power minus 3 goes in the numerator, what will happen there? 10 to the power minus 1. Okay, 10 to the power minus 1. So 8. Okay, if I eliminate 5, 10, that will be 2. Okay, so 8.85 into 2, that will be 17.7. Okay, 17.7. Now 10 to the power minus 3, if it goes to the numerator section, so what will happen? Let me write 10 to the power minus 12 into 10 to the power minus 4. to the power minus 4 into 10 to the power plus 3. Okay, so what will become? Minus 4 plus 3 is minus 1, and minus 1 minus 12, that will be minus 13. Okay, that will be minus 13. Okay, as it is in the power, okay, 10 to the power will be added or subtracted as per their sign convention. Okay, so the answer will be 17.7 into 10 to the power minus 13. Okay, 10 to the power minus 13. Now if I make the final formula now, so we have to find the V, and the V will be what is happening? B is equals to Q. What is Q given? 20 into 10 to the power minus 12. Okay, 10 to the power minus 12. 20 into 10 to the power minus 12. Very simple calculation. As I am taking the digital pen, this is really problem. Okay, but if you are taking a ballpoint pen, it will be a simple a matter of second. Okay, 10 to the power minus 13. Okay, how much? Minus 13. Now if minus 13 goes in the numerator section, what will happen? Minus 12 into, okay, 20 by 17.7, that will something become 1.1. okay, 1.1. Now 10 to the power minus 12. Okay, let me approach it completely. Minus 12 into 10 to the power plus 13. Okay, now plus 13 minus 12, that will be plus 1. Okay, that will be plus 1, and so finally what will becomes 1 point, what is happening? 1 point 1.1 into 10. 1.1 into 10. Okay, that is something 11 point something. Okay, 11 point something. Okay, without any calculator I'm just solve it. Okay, but do not make use of calculator, because if you try to use the calculator at your home, in your examination hall, you can't solve it. Okay, then you have that is a requirement of calculator suddenly needed by you. Okay, but don't try to that malpractice in your home. Try to practice with your pen and paper. Okay, coming to the next point, next question. Now a very simple circuit is given, and you have to calculate the resistance between the point X and Y. Okay, how to approach? You have to find what is the direction of the current. Okay, the current direction. Now if I see that from the point P, the current is divided into two parts, in this point and this point. Okay, so what will happen? This is a parallel circuit. Now at the point Q, the current is just not, there is no current division. Okay, current is just moving from 4 ohm to 2 ohm. So if there is no current division, that is in series. Okay, now if you are a expert, okay, then it is a very simple approach. Okay, 4 plus 2, that is series combination 6 parallel 3, that is 2 ohm. Now 2 ohm, that is a series combination of 2 ohm, that will be 4 ohm, 4 ohm, that will be a parallel combination of 2 ohm, and 2 ohm, parallel combination of 1 ohm. Okay, so what will happen? Now if you are a very beginner, okay, then I would suggest you that try to solve it very step by step approach from the beginning. Okay, from the beginning, if you solve it by step, in the latter you don't have to make any steps. Okay, in latter you don't have to make any steps. Okay, now 4 plus 2, you can see suddenly the 4 plus 2 will be a series combination, that is a, there is no current division, so series combination, that is 6. So now it will become one resistance, that is 6. Okay, okay, I have to just use the eraser once more because this is so irritating for me and for our viewers too. 6, that is, okay, what is happening there? Okay, 3, okay, this is 4, this is 2, this is 2. Now this 3 and 6, these are parallel. Okay, if this is a parallel combination, what in our next step what we can write, 3 parallel 2, that is 3 into 6. Okay, 3 into 6 by 3 plus 6. 3 into 6, 18, divided by 9, that is 2. Okay, so it will becomes 2. Now this becomes 2, and now there is another 2 parallel path of 4. This is 2. Now this 2 and 2 are in series because there is no current division. There is no current division. Okay, this is 2, this is 4. Okay, this is 2 plus 2, this is also 4, sorry. So these are the parallel circuit. Okay, now this is a 2. Now 4 plus 4, that is 4 parallel 4, there is 2. Okay, 4 parallel 4, that is 4 into 4 divided by 4. 4 into 4 divided by 4 plus 4, that is 2. That is here 2. So 2 parallel 2, that will be 2 into 2 by 2 plus 2, that will be 1 ohm. Okay, that will be 1 ohm. Okay, let me approach it. It's very simple again. First 4 and 2, the 4 and 2 will be 6 ohm. Okay, 4 and 2 will be 6 ohm because it is a series combination. If it is a series combination, it is a 6 ohm. Now 6 and 3, they are parallel. Already we can see from the point P there are current division. So current, if there is current division, that is means parallel. So 3 parallel 6, that is 2 ohm. Now 2 and 2, this 2 and 2 are in series combination because there is no current division. 2 plus 2 will be 4. Now this 4 and 4 are current division. Okay, current division, again I can apply the current division. 4 parallel 4, that is 2 ohm. Okay, 4 parallel 4, 2 ohm, and this is already 2 ohm. So what will be the 2 ohm parallel 2 ohm? That will be 1 ohm. That will be 1 ohm. Now this is the answer between the point X and Y. What you have to do, you have to find the current divisions. Okay, whatever there, the current, if there is current division, if there is current division, apply the parallel formula. If there is no current division, apply the series formula. Okay, that is a simple trick. Next, determine the power delivered in watt by the current source for the given electrical circuit. Now what will happen here? Okay, first power delivered. What is the formula for the power delivered? There is P, and that is equals to I square R. Now here the R is a R equivalent. Why? Because there is a circuit. Okay, so we have to approach from the source. We have to approach from the source. Okay, if this, again I am applying the series, applying the current division concepts. Okay, if I am applying the current division concept, what will happen? That is, here the current is divided. Now here the current is not divided. So if the current is not divided, that means 2 ohm and 2 ohm are in series. If 2 ohm and 2 ohm are in series, that means there will be 4 ohm, and this 4 ohm and 4 ohm parallel, that means 2 ohm. Now this 1 ohm, 2 ohm, final, what will be the final figure? 1 ohm, 2 ohm, and final. Okay, let us remove some. Okay, this is 1, this is 2, and this is our 4. Okay, so this combination are in series, so the equivalent will be 5. 2 plus 2, series combination, no current division. 4 parallel 4, there is 2. 2 plus 2, this 1 plus 2 and 4, these are 4, sorry, this 2 say plus 2, there is series 4 plus 4 parallel 4, there is 4 parallel 4, there is 2. Okay, this will be 2. Okay, now this 1, 2 and this 2, these are all connected in series combination. So what will happen? 2 plus 2 plus 1, there is 5 ohm, and that is connected in series. Okay, now what is I? I is already given, there is 4 square. Okay, okay, there is 4 square, 4 square into 5, that is 20. 4 square into 5, that is 4 square 16, 16 into 5, there is 80. Okay, that will be 80. That will be 80 watt. Okay, so remember this formula and remember all the tricks to find the R equivalent. Okay, so we are just completing the video here. Okay, if you like the video, please share the video, and if you are watching our videos and you don't have subscribed already, please subscribe our channel and support us. Okay, thank you, and of course press the bell icon, because the bell icon will give you the notification whatever the video we will upload. Thank you.